Hey everybody, we're doing 3.3 day 2 today. Hopefully you're making today a happy day. All right, so our first 2 slides, actually maybe our first 3 slides, are just review from Algebra 1. Does this look familiar at all or not? No, I probably had about 4 people told me they remembered this from Algebra 1, but no, most people had forgotten. So what this is called is function notation. Basically right here I've got a function m. Function m equals x plus 7. That's the part of the function you would be using, just the right-hand side. And then this is function p. P of x equals 2x plus 1. This is the side you'd actually be using to do your calculation. So then they have, once they set their functions, they have you do calculations with the functions. So they would say, let's do m of negative 5. What you would do is you would take the negative 5 and you would substitute it in place of x in function m. So the calculation would be negative 5 plus 7. And that solution then would be 2. Does that make sense? Now does it look a little more familiar? You remember doing it? Awesome. All right, so for the next 3, I'll just give tickets out so people can give me the answer. All right, let's go with Madison. What'd you get on the second one?
Would that be, for 4 for x would be 2 times 4 equals 8 plus 1 equals 9?
Perfect. So she took the 4, put it in function p, so did 2 times 4 plus 1, and 9 is good. All right, what about Nick for the third one? Perfect. Questions on that one? Let's go with Cassie for M, last one. Good. Sounds like a lot of you guys remember how to do small calculators. So any questions? The letter tells you where to go, the number tells you what to put in for x. Easy peasy. Good. All right. So, are these the same functions? Yeah, same exact functions, but a little different now. This is when you almost have like 2 math problems within 1 math problem. It gets crazy. Do you remember in math class if you have more than 1 set of parentheses that you always start on the inside? Yeah? Okay. So we are actually going to start with this operation. We're going to start by finding p of 2. So we're going to put a 2 up here in equation p. That would be 2 times 2 plus 1. So it would be what? 5? So this solution is 5, but we're still not done. See that m? We now have to find m of 5. So take your 5, go to equation m, and do 5 plus 7. So the final solution is 12, but it was almost like a 2-part problem. Did you follow the process on that? Awesome. So we'll have you guys try the second one all by yourself. Just raise your hand if you get it, and I'll give you a ticket. All right, let's go with Nick. Is it 9? Wait a minute. I lost my train of thought. Yes, it is. Perfect. Okay. So m of negative 3, you're going to put your negative 3 in for x right here in equation m. So that'll be negative 3 plus 7, so it's 4. And then p of 4, you're going to put a 4 in equation p, so 2 times 4 plus 1, that's going to be 9. Perfect. Questions on the last one? Yep, I'll keep it. All right, so this is what we're going to be doing next. We are going to be doing composition of function, and this is when you're going to be using 2 or more functions at a time, and you're going to be putting a whole entire function inside of another function instead of putting numbers in. And then where we're headed with this, of course, is we're going to be doing the composition, but then looking at the domain when we're finished. It's not going to be too big. So just like on the last slide, we're going to start with the most inside set of parentheses, and that would basically be n of x. So we're going to take n of x, I like to circle it, circle, and we're going to be placing the whole entire function n of x inside function m in place of x. So this is going to be crazy. I'm going to use a visual, so everybody watching my hand. I'm basically going to pick this up in a ball, come over here and plop it in place of x right there. See that? So it will be 6 parentheses negative 7x squared. That's where I plop function n of x plus 8. You see how that works? It's very weird, and you have to definitely visualize what's happening. So you have to pick it up, you place it inside of this function in place of x. You substitute it in. And then you're just going to simplify, and then you're going to figure out what the domain is. So simplifying this is easy. 6 and negative 7 can multiply. And then you're done. And you just sit back and you're like, huh, what would the domain be? What would I be allowed to square? That's what you're doing with x. You're squaring x. Can you square a negative? Can you square a positive? Can you square 0? Yes, yes, and yes. So the domain is all reals. Negative infinity through infinity. All right. All right, I'm going to have you do the top 2 by yourself for a ticket, and then we'll do these bottom 2 with one another, because those are the harder ones that are new for today. I'll pause this and let you work on them for a sec. All right, so I gave them some work time, and we did get an answer from a student. She put a 2 in for function g, so she basically did 2 squared, got 4. And now she's going to put a 4 in function f, so she'll do 2 times 4 plus 5, and that's 13. Perfect. Here's your anybody else got the second one figured out? G of f of negative 3. Andrew?
1.
It's positive 1. Perfect. So he took a negative 3, went to equation f first, which was 2 times negative 3 plus 5. That gives him negative 1, gave him negative 1. And then when you take your negative 1 and square it, it gives you a positive 1 for the answer. All right, we'll do these next 2 together because they're a little bit harder. So on this one, we're going to take function g, and we're going to circle it. So this is the guy you're circling, the inside guy. We're going to circle him. We're going to travel to function f and stick him in place of x. So it'll be 2x squared plus 5. There's really nothing to simplify down on that one, so you're done. Easy peasy. What would the domain be? What are you allowed to square? Anything. We just talked about that a second ago. Negative infinity to infinity would be your domain, because you could put anything in for x that you wanted. All right, we have to do it in reverse. Now we have to circle function f and put it inside function g. This one's a little bit harder. So we're going to circle function f, travel to function g, put it right there. So it'll be 2x plus 5 squared. Do you remember how to simplify that down? Can you distribute the squared? No. I saw some people shaking their heads. Yes, we cannot distribute the squared. Andrew said it. Foil time. And that's when I went. somebody yell, I love foiling! What, does Spencer like foiling? Spencer foils everything, even when he's not supposed to. Yes, that's true. Oh gosh, he might be watching the YouTube video because he's absent today. We miss you, Spencer.
I'll ask him if he can.
Hopefully you're on a field trip with the Magic School Bus today. Alright, so that's going to be 4x squared, 10x, 10x, and 25. You can add your two middle like terms, and you're done. Will this have the same domain as the original one then? This one over here, f of g of x? Yeah, it does, because you can square anything. So domain is negative infinity to infinity. So hey, we did f of g of x, and then we did g of f of x. Did we get the same answer or a different answer? You got the same domain, but you got a different answer. And what that means is function composition is not commutative. You can't do it forwards and backwards and get the same answer. Addition is commutative. 2 plus 2 equals 3 plus 2, but function composition is not. So I have that on the slide. You don't need to waste the time writing it down, but basically if you would put one inside the first and then put the second inside, do it in reverse, you're going to get different answers. All right. Let's do a multiple choice one. Go ahead and try this one by yourself, and then we'll check it. All right, we're back. Does anybody have an answer they want to share? Emma. So Emma got D. Let's go ahead and check her. So when you take that 3 and you go into function f, you do 2 times 3 minus 7. That would be a 6 minus 7, so you get negative 1. But now you have to head to function g with it. Make sure you remember, if you're squaring a negative, it has to go like that. And so it would be a 1 plus 4, which is 5. Very good. All right, the class wanted to give a shout out to Carly Walsh. Hopefully you're at home watching the YouTube video right now, and hopefully your surgery went well. We miss you. Lauren will Snapchat you soon. All right, we're going to do this as our last one. I have a little star there because I wanted to tell you something about function f. So we are going to rewrite function f to make it more user-friendly. I have a little song. I bet you know what it is. No, not bigger minus smaller. Flip and make it positive. So the 4 does not flip. The 4 is not attached to the x. The x does flip, so it can have a positive 1 as its exponent. So right off the bat, I'm thinking, ooh, this is a division problem. I want to be careful not to divide by 0, okay? Because you're not allowed to divide by 0. Yeah, so I'm already thinking ahead. I know we're going to be asked domain questions. I'm already thinking, let's not include 0 in our domain. And then g of x is, of course, 5x minus 2. I don't know why I wrote that wrong. Yeah, we're going to do all of them. Well, we'll answer the domain as we go. So let's do f of g of x. So which one am I circling and where am I putting him? I'm circling g, and I'm putting him in place of x right there. So it's 4 over 5x minus 2. And there's no simplifying to be done, so that is the answer to f of g of x. Let's do the domain right now while we're thinking about it, though. What did I say? You're never allowed to divide by in math. 0. So could I stick a 0 in for x? Yeah, I could. 5 times 0 minus 2 is just negative 2, and that would work fine. So it's another number that we need to figure out. So if you can do it in your head, awesome. If you can't do it in your head, do it like this. Write down that 5x minus 2 cannot be 0, and then just solve it like an equation. Add a 2 to both sides. Divide both sides by 5. So x is 2/5. Or x cannot be 2/5. So the domain would be all real numbers except for 2/5. Yep. All real except 2/5. I should hit this button so we can actually see everything we're doing. There we go. Perfect. That was part A. Everybody's okay on why we're excluding 2/5 and not excluding 0? It's because there's a lot more going on in that denominator than just a single x. All right, part B, g of f of x. So who am I circling and where is he going? I shouldn't make so many lines. I'm going to circle equation f, and I'm going to put it in equation g in place of x. I accidentally erased part of my equation g, but I think you know what it is. It's going to be 5 times 4 over x minus 2. Can you clean that up for me? What would it look like? 20 over x minus 2. So that's your answer. And then what's the domain going to be? Yeah?
Why isn't it 5x or like 20 over 5?
We have a 5 over 1 here. Does that help?
Yeah.
So you do the 5 times 4 and you do the 1 times x. Domain, what is it? Who can I not divide by? So the domain is going to be all reals except 0. And if I want to do part C, I'm going to have to erase all this to give myself some room. So let me know when you're ready. I'll pause it so you can catch up, and then you'll erase everything. All right, our last one, part C, f of x. What? What do you think we're going to do? Plug it in where? Plug it into itself, basically. So this might sound crazy, but to help me visualize it, when I was first learning this, I would write the equation out twice so that I could literally see something circled and I could draw an arrow and I could see where I was placing it, okay? So we're taking function f, putting it into function f. So we're going to circle function f, we're going to put it into function f right there, okay? So it will be 4 over x. Now somebody told me they were doing stuff like this in physics right now. Anyone in physics doing this right now? What do you do when you divide by a fraction? I think you learned this in 4th grade or 3rd grade. You multiply by the reciprocal. So to clean this up, I'm going to take my numerator, my 4, and I'm going to multiply it by the reciprocal of this fraction. Now keep in mind, that's 4 over 1 right there. So what will happen? Yeah, you just have a positive x coming up. The 4s will cancel. So I looked at that and I'm like, oh, my domain will be all reals. I can put anything in for x. But you have to consider your original functions. Our original functions, you could not divide by a 0. So you want to exclude 0 from your domain. So all reals except 0. All right, so we're done. I'm going to stop the video. And the homework is a worksheet. I'm going to pass it out now.